Hello friends, welcome to lecture number 20. In today's class, we'll study about insertion of dielectric at constant charge and then we'll study about it at constant potential. So these are the two very important topics as far as your JEE main is concerned. In all entrance exams, questions from here is a mandatory. Okay. So without wasting much of the time, let's start. Insertion of dielectric at constant charge. First of all, let us understand. In the previous class, I have done about told you about insertion of dielectrics. But what is at constant charge? What does it mean? Okay, so basically, it means the capacitor. It means the capacitor is fully charged, and then the battery is cut off. Okay, now there is no place for the charges to flow. Okay, so where they will remain? So they will remain in the capacitor. Okay, so this is the exact meaning of constant charge. So this thing have already been done. Now what we do, we will slowly insert the dielectric into the capacitor. Now what happens during this insertion of the dielectric? You will see that if I leave the dielectric, then it will there will be an attractive force on the dielectric. So FDI, which I denote, it will allow the dielectric to pass through the capacitor. But that is not my objective. My objective is to insert the capacitor slowly. So what I have to do then? Then I have to apply an F external in this direction. This F external will allow the dielectric to enter inside the capacitor at a constant velocity. Okay, so what is then your F external? F external is the force with which we pull the dielectric upwards, and we do so that the dielectric can smoothly enter inside the capacitor. So FDI is dielectric, force on the dielectric. So this is the force with which the dielectric, I am denoting by capital D, is dragged towards the plate. Okay, followed? Fine. Now there are many points which you should understand, and questions will come from these points only. So during the entire process, what remains constant? Q is constant, and we know C is equals to Q by V. This implies my C is inversely proportional to V. So what is the C initial? C initial means capacitance without dielectric. It was epsilon naught A by D. And what is CF? After the dielectric is inserted in the capacitor, your capacitance is epsilon naught Ka by D. So this implies my C capacitance increases because of the insertion of the dielectric, which we have also learned from the previous class. Okay. Second point, you know V is equals to Q by C. This implies V is inversely proportional to 1 by C. If C is increasing, then what will happen to V? V will decrease. This is also one of the information which you can draw from this. Okay. Then third one, what about the energy? We will look into the energy of the capacitor. Okay. So energy is denoted by Q square by 2C, which we have already derived. Now if C is increasing, this implies E has to decrease. Why? As Q is constant. Now the question comes, why is that the energy of the capacitor is going to decrease? What is the reason behind it? Okay, let us find out why energy is decreasing, right? Who is taking that energy, right? So what is the work done due to this external force? It will be force into the displacement, and this external force is a upward force. It is your upward force into the displacement. Now displacement of whom? Displacement of dielectric. In which direction? It is downwards. Dielectric downwards. Okay, so what will be the angle? Angle theta will be how much? 180 degree. So your work done due to the external force is going to be negative. Okay, it is going to be negative. So how can you calculate the work done by the external agent? By the external agent, what it will be? External agent. This will be equal to q square divided by 2 into d by epsilon naught Ka minus q square by 2c. C means it will be d by epsilon naught A. Here it is when the dielectric inside the capacitor, here without the dielectric. Okay, then what will be the difference? So q square by 2, it will be d by epsilon naught Ka minus d by epsilon naught A. So this also comes as a question. Find what is the reason behind the energy decreasing, or find out the work done by the external agent. That is also an important question which comes. Okay, then the fourth point. Let us focus on the fourth point. Here we'll talk about your electric field. So before the insertion of the dielectric, what is the electric field? We already know sigma by epsilon naught. Then what is your after insertion of the dielectric? Sigma by k epsilon naught. Sigma is nothing but q by a epsilon naught, and here EF will be q by a k epsilon naught. Q is constant throughout this process, so your electric field is doing what? It is decreasing, as it only depends on K. Okay, so the electric field will go on decreasing. The fifth one, force between the capacitor plates. Okay, this is a very important one which you should understand. First, let us talk about when there is no dielectric. When there is no dielectric, we'll talk about this situation. We have got the plates. This side is positive, this side is negative. Okay, now I want to find out what is the force on this plate due to the other. Okay, so we know force is equal to Q into E. So this force will be how much? Charge Q into, what is the electric field? Sigma by 2 epsilon naught. You will ask me, sir, why sigma by 2 epsilon? It should be sigma by epsilon naught. I am calculating because of this plate. Due to this plate, what is the force? So on this plate, what will be the electric field for this plate only? It will be sigma by 2 epsilon naught. From Gauss law we know it. Okay, so therefore it should be sigma by 2 epsilon naught. So this is equal to Q into, sigma is nothing but Q by A into 1 by 2 epsilon naught. So the force now becomes is equal to Q square by 2A epsilon naught. So this is the force when there is no dielectric inside. Okay, but what happens when the with the dielectric? So with the insertion of the dielectric, let us see what situation it takes place happens. Okay, so what will be the diagram then? Here you have got two plates and you have the total dielectric which is inserted inside the parallel plate capacitor. Okay, so the charge here was plus Q plus Q plus Q plus Q plus Q. What is the charge induced inside the dielectric? Negative here, positive here, and here it will be negative. So this we already know it. This is minus Q, this is plus Q, and here it will be minus sigma I, and here it will be plus sigma I. This picture we have already done. Now again I want to find out what is the force on this plate. Force on this plate. Now in this plate the force will be due to whom? It will be due to the negative plate on the charge q because of the minus q, and minus sigma I, and because of plus sigma I. So we have to calculate this force. Okay, so force will be equal to q into the electric field due to minus sigma I plus electric field due to plus sigma I plus electric field due to minus q. Okay, now a very important thing you have to understand here: your electric field due to minus sigma I and electric field due to plus sigma I doesn't give any field outside the dielectric. This we have already explained also. Okay, so they cancel each other, followed. So for this, the contribution due to these two will be how much? They will contribute to 0. Then what is left out? It is F is equals to Q into electric field due to minus Q. How much it was? Q by 2A epsilon naught, which we have already calculated. So F is equal to how much? Q square by 2A epsilon naught. And what was here? Q square by 2A epsilon naught. So the question, so do we find any change? So we can conclude that no change in the force exerted by a plate on the other plate. Okay, so options come in the exam that whether the force increases, decreases, no change, okay, or depends on Q. So all these things come. So what is the correct answer? No change. Okay. So I hope all of you understood this. Clear? So these are the things what questions will come when the dielectric is inserted at constant charge. Okay. The next part which we will talk about is your insertion of dielectric at constant voltage. Okay, so what happens here? In the previous case we used to cut off the voltage, but here the voltage will be there. This is the parallel plate capacitor, and this is connected to a particular voltage which remains throughout the insertion process. And what is the dielectric here? Here you will have the dielectric which is inserted, and this dielectric have a dielectric constant K, and F external will be along this direction. Same reason as I explained in the previous case, so that it can enter slowly at a constant velocity. Okay, now let us see what all changes we encounter at constant voltage. Okay, so for first one, when V is equals to constant, then what will happen to C? C increases. Your C will increase. Why is it so? Because C initial is equal to epsilon naught A by D, and your C final will be how much? Epsilon naught K A by D. So C will increase, right? The second one, we know the relation Q is equals to CV. V is constant. This implies Q is proportional to C. If C increases, so Q will also increase. Got it? Then the third one will talk about the energy of the capacitor. Energy of the capacitor. Its value is how much? We have already derived half CV square. So V is constant in this case. If V is constant, C increases. This implies my energy of the capacitor will also increase. Okay. Then fourth one, what happens to the electric field? Okay, what happens to the electric field? We know that the electric field is V by D, and V is constant. So what does it mean? It means my electric field will also remain constant. That means electric field, there will be no change. Okay, there will be no change. Then the fifth one, let us calculate force between the plates. We have already done the detailed process in the previous derivation. So force between plates. Okay. After the, let us calculate the force once the dielectric is inside the capacitor. So I write F final. So what will be F final? It is nothing but your Q square by 2A epsilon naught. So let us now find out what is Q square. We know Q is equals to CV. But because of the insertion of the dielectric, your C becomes how much? C will increase by K times. Okay. So if I put this in this equation, your Q will be how much? K C V. Okay. So this is what you will get. So instead of Q square, what I can replace here? F final will be how much? K square C square V square divided by 2A epsilon naught. Let it give me as equation 1. Then what is F initial? F initial will be your Q square by 2A epsilon naught, which is equal to C square V square by 2A epsilon naught. Give it as equation 2. So comparing equation 1 and 2, what we find? That because of the insertion of the dielectric inside the parallel plate capacitor, the force increases by K square times. Question comes K times K square time K cube time. So it will be K square time. Okay. Then the next one, sixth one, it will ask you what is the charge flown through the battery. Charge flown through the battery. Calculate this. Okay, how to do this one? This will be equal to KCV, because we know after the insertion of the dielectric, Q is equal to KCV, we have already calculated, minus CV. So your CV is common, K minus 1. So this will be the charge flown through the battery. Then seventh one, what is the work done by the battery? Let us calculate that. Work done by the battery, it will be equal to charge into potential. Okay. So what is the charge flown through the battery? Just now we have derived CV K minus 1. And what is the potential? V. So what is the answer? CV square K minus 1. So this is the work done by the battery. Eighth one. What is the energy of the capacitor? Let us find out. Energy of the capacitor. Okay. So the energy of the capacitor, let us find out. Before the insertion of the dielectric, the energy was half CV square. After the insertion of the dielectric, it will be half KCV square. Okay. What is the change in energy? Delta E will be how much? EF minus EI. So it will be half KCV square minus half CV square. This will be equal to half CV square K minus 1. Okay. Therefore, your E final is greater than E initial. Okay. Followed? So these are the questions which will be asked in your entrance exams. So kindly see this video very carefully. Repeat it see it once again. Repeat to see these videos. Okay. So kindly subscribe my channel, like the video, share the video. Any queries you have, you can mail me in the mail ID which is given below. Thank you for your kind patience.